Okay, this is chapter 7, day 6. So chapter 7, day 6 of sampling distributions. This is the key lecture in this particular chapter. Okay, we're going to be working on 4 problems. 3 of them are proportions, 1 of them is a mean. Okay, and every proportion is also a binomial if you want to think about chapter 6 where the binomials are. Whether you've studied chapter 6 or haven't studied it yet, every proportion is also a binomial, and I'm going to conduct all these problems in that way as well. Okay, so every time we do one of these problems in a normal curve, the normal curve is actually an approximation to the answer. But it's so close, we just accept it as probably the real answer, but it's still considered an approximation. Okay, so the first thing you're going to do when you see these problems is you're going to ask yourself, do I have a mean or do I have a proportion? Okay? And then let's go through them. All right, first problem. A poll conducted on Prop 30 had an approval rating of 48% with a sample of 1566. What's the probability will pass? So in my mind, 50% is passing. We're wondering if this sample, what are the chances that 50% actually would happen in the real election based on this sample? Okay, so let's go through this. We're going to draw a normal curve, which you've done so many times. We got a raw score, we've got a z-score, and we got a percentile. And on this raw score, we got 0.48. 0.50 is in the tail somewhere, and we got to calculate the standard deviation. And the standard deviation is going to be p, 0.48, times 1 minus p, 0.52, over n 1566. And I've previously done the calculations. It's 0.0126 is the standard deviation. Now we got to get a z-score for 0.5. Z-score is how many standard deviations you are away from the mean. So that z-score is going to be 0.50 minus 0.48 divided by 0.0126. And that comes out 1.59 is the answer to that, 1.59. All right, that's the z-score, 1.59. I'll put it on my chart. And now I'm going to get the percentile rank. I'm not going to show you the calculator work on this because I'm assuming you can do it. But you're going to go to second vars or second distribution, and you're going to go to NCDF. It probably says normal CDF on your calculator. And you're going to type in 1.59, comma, some form of infinity. Probably the number 1,000 is just fine. 1.59 infinity, and that's going to come out 0.0562 or thereabouts. Okay, so 0.0562. So that is the approximate answer using the normal curve, which is basically an approximation, a normal approximation to the binomial. Now, let's just look at chapter 6. I know this is not part of this chapter, but I wanted to show you the exact answer to this problem. So the exact answer to this problem is embedded in the binomial distribution. All percentages are binomials, if you think about it. You either vote for it or vote against it. It has all those qualities of just 2 things happening. So the first thing I'm going to do this, and I'm going to do it on the calculator after I execute this, is I'm going to figure out the probability of half the people or less voting for it. So we got 1566 is the number of people that are in this poll. 0.48 is the probability of voting for it. And half of 1566 is 783. Okay? Once I get that number, it's going to be in the 90%, obviously. It's going to be the complement of that. I'm going to go 1 minus that. Okay? This pen is going crazy on me. I'm going to go 1 minus that. So if you think about it, it will make sense that I'm going to gather together 50% or less because the CDF is a cumulative function, and I'm going to go 1 minus that. And let's go ahead and calculate that out and see what that is. So write that down. I'm going to clear the screen and go to my calculator, okay? Okay. So on the calculator, I'm going to go 1 minus second bars, and I'm going to go to binomial CDF, which is cumulative distribution function. I'm going to type in 1566, 0.48, and 783. On your calculator, you're probably going to have to do 1566, comma, 0.48, comma, 783. And then when I paste it, you can see the back end of it and hit enter. And that's 1 minus that, and there's your answer, 0.0538. That's the exact answer. Now, the normal calculation that we did was an approximation, but this is the exact answer. Now, for the purposes of the Chapter 7 test, you do not have to do the binomials. You don't have to know them. But I just wanted to slip that in because I think it'd be a good review or preview depending on which order you're studying this. Okay? All right. Next problem. The next problem is also, also a proportion, okay? If you flip a coin 500 times, what is the probability that you get 275 or more heads, okay? So the first thing you got to figure out is, what is 275 over 500? What percentage is that? And if you divide 275 by 500, you get 0.55. Okay. All right, so let's look at this. Again, this is a proportion. And a proportion is also a binomial. Okay, so in the middle goes 0.5, because that's the probability of getting heads. 275 over 500 is 0.55. That's going to go in the tail. And we're going to calculate this area right here. Okay? That area right there. I got to get the standard deviation. And the standard deviation is going to be P, 0.5, 1 minus P, which is also 0.5, over N, which is 500. And I have previously solved this problem, and it comes out 0.0224. All right, now I'm going to get my z-score. My z-score is going to be 0.55 minus 0.5 over 0.0224. And when you calculate that, you get about 2.23. 2.23. So the z-score is 2.23. Okay? And then when you put it in the calculator, you're going to go NCDF 2.23, comma, some form of infinity. Write infinity on a test or a quiz, but type in like 100 or 1,000 on your calculator. And it comes out about, depending on how you rounded some things earlier in the problem, about that, 0.0128. Okay, 0.0128. Okay, now, this problem can also be done as a binomial, which again is chapter 6, which you're not going to be tested on in this chapter. So if you're reviewing chapter 6 or previewing it, let me do that problem for you as well, okay? So in this situation, I want to know the probability of getting 275 or more. So 275 or more includes 275. So what I have to do is I'm going to go 1 minus binomial CDF, 500 flips, 0.5 chance of success, and I'm going to type in 274. This is going to gather together 274 or less heads. And when I go 1 minus that, I'm going to be left with 275 or more. Again, not a test item, just a review or preview connecting binomials to the normal approximation. to the binomial. Okay? All right, so I'm going to go ahead and erase this and put that on the calculator, and you'll see the answer. Okay? Okay, I'm going to go 1 minus second distribution binomial CDF. I'm going to type in 500 trials. 0.5 is the probability of heads. And 274 is what I'm looking for. Once I gather together 274 or less, I can take it and go 1 minus, and you're going to get the answer of 0.0142. That's the exact answer. The other answer that we got off the normal curve was an approximation. Both are fine. Okay? All right. So let's go on to the next problem. Okay, the next problem I'm going to handle as a proportion only. I won't do the binomial one, okay, but you can. A poll conducted on 1,501 voters regarding the legalization of marijuana had a 42% approval rating. What is the probability it will pass? That's one question. And what is the probability your next sample's approval rating will be between 40% and 45%? All right. So in the early days of the marijuana legislation in our culture, it was really not polling very well. Over time, it's gotten higher and higher, and many states, or almost most states at this point, have legalized it. And typically, when you do a sample, it's about 1,500 is the sample that Gallup poll likes to do. The reason for that, discussed later, is because it gets around a 3% margin of error, which most people think is acceptable. Okay, so I got two questions here. All right, so again, this is a proportion, it's a percent. Here we go. So the first one, normal curve is being drawn. 42 is the middle, and 50% is passing. That just doesn't seem like it's very likely, given that it's really far away from 50% at this point in the voting. Okay. So my standard deviation will be p 0.42, 1 minus p 0.58 over 1501. Okay? And that is 0.0127. That is 0.0127. Okay? Now to get a z-score on that, I'm going to go ahead and do that. The z-score will be 0.5 minus 0.42, okay, divided by 0.0127. And that comes out to be 6.30. Now we know that a z-score of 6.30 is a total outlier. And the p-value is going to be really, really small. It might even be essentially 0, meaning that this thing really has no chance of passing the way it's polling late in the game here. Okay? So I'm going to type in NCDF on my calculator. I'm trying to get this area, which isn't much, 6.30, comma, some form of infinity. Okay? And that will come out approximately 0. Okay, so at this point, if this poll was taken the night before the election, they sort of know that it's doomed, assuming we have a representative sample. There are requirements to all these things. And those requirements are spin. We've talked about that before. We're assuming we got a representative sample. We're assuming the population is 10 times bigger than this. We're around 15,000. We're assuming everyone's vote is independent. And we have enough samples for a normal curve because NP 1501 times p, 0.42, is greater than 10, and 1501 times 1 minus p, which is 0.58, is also bigger than 10. So we have if we make those assumptions, then we can safely assume if this poll was taken right before the election, this thing's not going to pass. Okay, that's how the inference procedure is going to work later on in probably chapter 9 or 10. Okay, so there's another preview of things for you. Okay, now the other question is between 40% and 50%. So let me erase this and set this up. Okay, between 40% and 50%. All right, no problem. So I'm going to draw the same curve, okay? And it's 0.42, and all between 40 and 45. Sorry about that, I said that wrong. Between 40, somewhere down here, 0.40, and 45. That's probably pretty likely to end up in there. Probably pretty likely, okay? The standard deviation is still 0.0127. I'm not going to recalculate that, all right? And now what I'm going to do is I'm going to get a z-score for both 0.4 and 0.45, okay? For 0.4, the z-score will be 0.4 minus 0.42 divided by 0.0127. And that z-score comes out negative 1.57. Negative 1.57. Okay? Now the z-score for 0.45 will be 0.45 minus 0.42 over 0.0127. Okay? And that z-score is going to come out 2.36. So it's actually pretty deep in the tail here, 2.36. And I'm going to find the area between these two things, okay? So this is actually pretty deep here. It's going to be in the 90%, I think. All right, so I'm going to type in NCDF on my calculator. I'm going to put the lower bound or left bound number, z-score, negative 1.57. Then the upper bound number, or z-score, of 2.36. And that's going to come out approximately 0.9333. Depends on where you rounded, because you may have rounded on, you may have rounded in different areas than me. Okay, 0.9333. Okay, so there is those two questions built in one. All right, the next question is our only mean question that we're doing. Most people recognize means much quicker, so it's pretty easy to do. All right, the mean SAT score is 1,600. Keep in mind, this is the old SAT score that was out of 2,400. This particular SAT only ran for a few years, so I'm just kind of going with an old set of numbers out of 2,400. The mean was 1,600 with a standard deviation of 200, okay? If we sample 30 students, what is the probability they average 1675 or higher? No problem, okay? So I'm going to write the average right in the middle. This is 1,600. The standard deviation is 200, and there's 30 students. So sets of 30 students will have this particular deviation, okay? What is the probability they average 1675 or higher? I'm not sure where 1675 is out here, but I got a feeling it's going to be pretty hard to get 30 students to average this randomly when it should be this. And again, let's go over the conditions for this. For us to draw a proper conclusion, SPIN, that acronym's got to be in play. We got to have a representative sample. I'm assuming we do. We have to have sampling less than 10% of the population. I'm assuming there's more than 300 LQ students that have taken the SAT. Every score should be independent. And then the last n, we got to have a normal curve. And we know the central limit theorem ensures normality when you have at least 30 samples. So we're good on that. Okay, now I'm going to get my z-score here, okay? That's the raw score. Here comes the z-score. And the z-score I'm going to put out here. This will be 1675 minus 1600 divided by 200 over the square root of 30. That's how you get the z-score, okay? And that particular z-score is just over 2. It's 2.054, which I should round to 2.05 because we're trying to go to 2 spots every time. If you round differently at different spots, you'll get slightly different answers. And then we're going to do NCDF, as you guys are used to doing. 2.05 and then, or higher, and some form of infinity. Write infinity on your test, put in 100 on your calculator, and you are going to get a p-value of around 0.0200, somewhere around there, okay? It might be slightly different if you used a different z-score or rounded differently somewhere, but around 0.02. So there's only about a 2% chance that we would get a sample of 30 that average 1675 or higher. Now, an individual can get out there, but it's hard to get a random sample of 30 out there. It's very difficult to do. Okay, last problem, and there's a couple of typos on this problem, which I will guide you to, okay? And I'm going to do this literally 3 different ways, okay, at the very end, okay? Okay. The last example is not example 4, it's actually example 5, and the question is, what is the probability that you roll 100? I forgot a couple words, 100 or more out of 500 ones in a die, okay? Do this as a proportion and a mean, and I'm going to also do it as a binomial, okay? Your job is to know it as a proportion. My job is to make sure I review and preview binomials for you. And it's just good to know that you could do it in whole numbers as a mean as well, okay? So let's try this. So the first thing you should do is be able to know it this way. Okay, so let's go ahead and draw the normal curve out, okay? Now, the typical number of percentage or proportion of ones you're going to get is 1/6. 1/6 is like about 17%, 0.16667, okay? 100 out of 500 is 20%, okay? So that would be, that goes in the tail. And that's actually probably going to be pretty hard to get, 20%, when you should get about 16 or 17% in a set of 500. It's probably pretty uncommon. Okay, now here's your standard deviation. 1/6 proportion of ones, 5/6 proportion of non-ones, divided by 500, which is the total. And that number comes out to be 0.0167. Now we're going to have rounding issues all the time here, depending on where you rounded. Here's my z-score. Is 0.2 minus 1/6 divided by 0.0167. And that comes out 1.994. 1.994. Now I forget what I typed in when I did this, but I'm going to go ahead and round to 1.99 for my z-score. And then I'm going to go NCDF. I'm going to type in 1.99, comma, okay? Comma, some form of infinity, probably type in 100 or 1,000, and you're going to get an answer of about 0.0231. Now I'm going off my notes, so I forget if I put that z-score in or I put 1.99 in, but it's 0.0231 about. Okay, great. Okay, so there is There's how to do this proportion. That's just what you are expected to know. Now, let me erase this. You can actually do this as a mean as well, which just means you're just putting everything in whole numbers. It's not the mean like the other question that we did previously, okay? And all I'm gonna do is, instead of putting 1/6 here, all I'm gonna do is I'm gonna write down, what is 1/6 of 500? Well, that is about, come on now, 83.3, okay? About 83.3 ones are expected per 500 rolls, which is 1/6 of 500. Multiply that in your calculator and you'll see that, okay? Then the standard deviation, I'm gonna move 500 into the numerator. I'm gonna take it out of the denominator, and I'm gonna go 500 times 1/6 times 5/6, okay? And when I do that, I'm gonna get a standard deviation of about, and this is the that's not unrounded, but 8.333, okay? And now I'm gonna go ahead and put 100 in here, okay? And my z-score is gonna be, z-score will be 100 minus 83.3 divided by the standard deviation of 8.333. And you got some rounding errors going on here because this could be 8.3 continuous as well. You're going to get a z-score, in this case, I believe, of around, this comes out like 2, okay? Z-score is around 2, about. So I'm going to put in the about 2. Now, if you remember, the proportion was 1.99. They're actually the same exact problem. We just have some rounding errors. I want you to recognize that. But all I did was change the standard deviation to whole numbers by taking 500 out of the denominator and putting it in the numerator. And then, instead of putting 1/6, I put 1/6 of 500 and made that a whole number. Then, instead of putting 20% of 500, I put 100 because 100 is the actual number you're going to get. It's actually the same calculation. And if you didn't round at all, you would get the exact same z-score, okay? Then, of course, after you do this, you're going to do the z-score is 2, and CDF 2, comma, some form of infinity, and you're going to get about 0.0227 in this case. But really, they should be about the same answer. And they almost are if you look at the two answers. And again, these are both approximations because we have rounding issues as well. Okay, so we're now going to do this as a binomial. Again, I'm reviewing chapter 6 or previewing depending on which order this is taught. Okay, and this is not something you got to know for the test, but it's just great to have. So for a binomial, 100, remember it's 100 or more. So 100 or more includes 100. So what I've got to do is I've got to go binomial CDF, and I got 500 rolls. And I got a 1/6 chance of getting a 1. And I'm going to do 99 here. Because if I gather together the probability of rolling 99 or less ones, 99 or less ones, and this is the or less function, and then I go 1 minus that number, it will leave me with 100 or more ones out of 500 rolls. Okay? So I'm going to do that now. So get that written down, and I'm going to do that now on the calculator. Okay? Okay, I'm going to go 1 minus second distribution binomial CDF, and I got 500 trials. The probability of success is 1/6, and I want 99. So I'm going to paste that all together and click it, and there is my exact answer. So the exact answer to this is 0.0283. The other ones were approximations, and they're fine for this. Okay, this is the key lesson for Chapter 7. Thanks a lot and good luck.